Okay, so we learned that when we have any similar solid, that means that the ratio of the lengths are proportional. Then we have a special relationship with the lengths, areas, and volumes. All right. If you don't remember, please look at the previous two videos about similar solids before working on this. Okay, so now we're going to learn how do we actually apply the information when we're trying to find specific areas or volumes for similar solids. So let's use this example here. I have information for solid number 1 and solid number 2. It doesn't matter if it's a cylinder, cone, sphere, whatever. As long as you know they're similar, you don't even have to know their formulas. Okay? So here's how we work this sort of problem. We would like to do a know, want, need chart. Okay? We want the surface area of the second solid. All right? What is it that we know? Well, we know the volumes of both solids. And we know the surface area of solid number 1. But we need solid number 2. Well, these are similar, which means what? We have to have a proportion. In order to have a proportion, we need to have ratios. So the thing is, if we are looking for surface area, what ratio do you think we need to compare surface areas to? Is it going to be the ratio of length, area, or volume? If you guessed area, you would be correct. Okay, so we have to actually find the ratio of the area if we are trying to find area. So we need the ratio of area. So let's find that ratio based on the information we have. We know the volumes, so let's actually find the ratio of the volumes. 486 to 144 actually reduces to 27 over 8. Now, how is it that we're going to find the ratio of the area when we only have the ratio of the volume? Remember what I said before. What ratio do we always have to go back to? Length. Always go back to length. So we know that the family of ratios is ratio, ratio squared, and ratio cubed. So if 27 over 8 is the ratio cubed, what do we have to do to it? We have to cube root it. So let's go back to our calculators if you don't see it right away. Go to math, cube root, number 4, and then we type in 27 divided by 8. Remember, you can do math-frac. And there you go, you have the ratio of the lengths is 3/2. So let's write that down. 3/2. How do we find the ratio of the area? We square it, giving us 9/4. Now we have exactly what we needed. So if we need the ratio of the areas, which is 9 to 4, we compared, this is, remember, solid 1 to solid 2. So we have to make sure the corresponding areas line up. So the surface area for solid 1 was 45 square inches, and then we don't know the surface area for solid 2. Now it becomes a proportion that you can easily solve. You can use means extreme, but also remember, notice there's a scale factor here. 9 times 5 gives us 45, which means 4 times 5 would give us 20. So the missing surface area is 20 square inches. Let's do one more quick scenario. Now I'm asking you to find the volume of solid 2. So we want the volume of solid number 2. We know the surface areas of both, and we know the volume of solid number 1. So if we want to find volume, what ratio do we need? Hope you said ratio of volume. You always compare with what it is that you need. Okay? So we know the surface areas of the solids, so that's the ratio that we know of. So I'm going to do solid 1 to solid 2, so that's going to be 10 to 810. When that reduces, that becomes a 1 to 81 ratio. All right, I hope I'm sounding like a broken record now. If I want to find the ratio of the volume, how do I go about doing that? I hope you said go back to the ratio of the lengths. Always go back to that base. Then you can easily cube it. So you take the square root of 181, which will be 1/9. And then we cube 1/9 to get the ratio of the volume, which will be 1/729. I know that's a big number, but it will work. Now that we have the ratio of the volume, we can actually solve for the volume. So solid 1 to solid 2 ratio is 1 to 729 of the volumes, and it's going to be a 5 to what? So when you solve the proportion, again, you can use means extremes, which would give us this. So it'd be x equals 3,645, and since it's volume, this is cubic feet. And there you have it. You can solve for the areas and volumes of any similar solids. Has to be similar, otherwise this doesn't work. And you don't even have to use any sort of formula. It works with any similar solid.